there, can you hear me?
Yep, all fine. How are you doing today?
I'm doing good. How are you doing?
Also fine. That is Monday. All week will be fine.
Yeah.
Before we start, let's talk about time borders. Do you prefer 30 minutes or 45? What do you think?
I think 30 minutes should be all right. That's what I usually do. Is that all right?
Yep, that's same for me.
Okay, cool. All right, so I'll looks like this is for me, so I'll go ahead and read this problem.
Yep.
Two sorted arrays are one or two possible numbers. As you find duplicates, it returns an array of all passport numbers that are both in array one and array two. Note the output array should be sorted in ascending order. Let n and m be the lengths, respectively. Solve for two cases, analyze the time, and space complexity of your solutions. M not equal to n. Array lengths are approximately the same, and n is greater than 8. All R2 is much bigger than array of 1. So I'm looking for duplicates between the two arrays. So in the first case, I'll just post this. Here. And it looks like the output should be 3, 6, and 7, since these elements all occur in both arrays. Okay. Um, so one solution that I'm thinking of is that for so the brute force way of doing this would be to iterate through each element in the first array, and then for each of those elements, iterate through the entire second array until we either find that element or iterate through the whole array. If we find the element, then we know that it's a duplicate, and then if we iterate through the entire array without finding it, then we know that it does not occur in both arrays. So I'll just put approach one, brute force, iterate through the array. First array and okay. And then so the second approach that I can think of here would be to utilize a hash map. So in this case, we would iterate through the entire first array and put or I guess it would be, I wouldn't need a hash map, I would need just a set. So in this case, I would have a set, and at each element of the first array, I would input that value into the set. And then once that is complete for the entire first array, I would iterate through the second array and find, and for each element, I would check the set, which I had already filled with values for each element. And uh, if it occurs in that data structure, then I know that it occurs in both arrays, and so then I can return that.
Yeah, and could you add time and place complexity for both approaches?
Sure. The time complexity of the first one, I would need to iterate through the second array um, every time for every element of the first array. So it would be uh, big O of n times n. where n is the size of the first array and n is the size of the second array. The additional space would be big O of 1 because I'm not creating any additional data structures here to hold any values here. So, well, I guess actually that's not necessarily true. I guess it would be, I would need a result array to hold the result to return. So I guess in that case it would be I guess the max of big O of n, big O of m.
Why do you think so? Why do you want to use a max?
Sorry, it'd be n. Yeah. So basically, whichever array is smaller, that's the maximum number of duplicates that can exist between the two arrays. So, that would be the additional space there. And then for approach 2, I would say utilize hash set, iterate through entire first array, adding elements to the set, and to and check if each element is in set. And so for this second approach, the time complexity would be big O of n plus m, because I'm going to need to iterate through both arrays. And then the space, additional space, would be big O of, so I guess in this case, I'm trying to think of, I want to optimize for space, obviously. So I could find the smaller of the two arrays and iterate through that with my set. So that way I need to use a little bit less space in the case that one array is much smaller than another one. So in this case, it would be the minimum, once again, the minimum of, and I would also need to return the result array this time as well. So it would still be big O of n, minimum of big O of n, big O of n.
Yeah, and like for second approach, for example, let's imagine that you have an array with length n, that is one element, for example, 1, and array like longest array has at least 10,000 elements. And your approach looks like you need to iterate over 10,000 elements, right?
Yes.
Could we try to find a better approach?
That's a fair point. So I guess if we find that all elements in the smaller, or so if we find that at any point we have a result that is the size of the smaller array, then we can just return, because then we know that there are no more duplicates to be found.
Yeah, but what if in array you have like in array with length n, in a shorter array, right? You have element like 1 million, and in array in longest array you have like 1 million elements, and the last element will be needed element. You still need to iterate over millionaire elements, right?
Still need to iterate through the longer elements. Sorry, could you repeat that?
Yeah, like in short array, you have one element, like 1 million, and in a long array, you have 1 million elements, and the last one will be 1 million element, like needed element. You still need to iterate over this array, right? From like first position till the end, and looks like that is not so fast for our search.
Yes, that makes sense. That would be slow. In this case, we need to know if 1 million exists in the second array. Um,
Yeah.
let's see. Okay, the two arrays are sorted.
Yes.
Okay, so um, interesting. So I know that, like, let's see, when we're comparing one element, um, we want to, if we know that we're seeing, for instance, a 3 in array 2, then we know that, like, there can be no 1s to the right of that. So what I'm thinking here is possibly, um, if we, say for instance that um, we have a large element in array 1, kind of like you said, so I'll make a new example. We have a 19, and then we have the same thing for array 2. If we're looking for 19 and we encounter 3, then we know that element 19 should be somewhere to the right of 3. And in this case, I guess it would be possible to perform like a binary search for an element greater than, or I guess equal to 19. And if we're unable to find that, then we would know where, uh, then we would know at least what position that it should be in, and we can only, going forward, look for elements to the right of that position that we found.
Yeah, looks like we can do it, and you can find something like a middle element, right?
Yeah.
And then decide, do you need move to left side or to the right side? Yeah,
Yes.
looks like that is possible.
Okay, so I'll take that down as approach 3. Um, let's see, we don't necessarily need a hash set, but in this case, we would say utilize binary search for each element in array 1. Find the, I guess, supposed index of that element in array 2. And if exists, add it to duplicates array. Otherwise, continue search to the right of continue search the right of that element, that index. So for time complexity here, in the absolute worst case, So let's say, for instance, that we have let's say, for instance, we have something like 2, 4, 5, 6, 7, and then we have the exact same thing for array 2. In this case, when we reach element 1, we would search through this whole binary search through this array, and that would be an ov log n operation. But then we would need to do the same thing for element 2, element 3, 4, and so on. So that would be, I guess, m log, or so I guess n log m,
Yep.
where n is the size of the first array and n is the size of the second array. And then for additional space, we wouldn't need to use any additional space for this algorithm, but we do need to return the result array. So once again, that's going to be the minimum of uh, linear space for these two array sizes. So yeah, this does a little bit worse on time complexity than using this hash set in the worst case, but in the case which you're talking about, with one element which is really large in the first array and one or a very long array with that element at the end of the array in the first one, this one would be much more efficient.
Yeah, but we know that approximately the same m much bigger than n, right? And that is why.
So sorry, say again, because there's two different cases, right? Where m is
Yes, for sure.
okay.
But like, I mean, still time complexity for n plus m, it will be, it should be slower than n multiply log m. But yes, sure, all depends on data. But in this task, yeah, let's imagine that we have correct data for binary search.
Sure. All right. Yeah, that sounds fine.
Yeah, let's try to implement it.
Okay, so I'll go ahead and implement approach number 3. So the first thing I'm going to be doing is, I guess I'm going to need result array. Um, hmm. So I need to implement a I need to return an array, but in Java, we need to give the size of the array at the beginning, or like on initialization, and adding space or adding an element to an array that's already full will result in we'll have to destroy the first array and create a completely new one. So I'm considering two approaches here. I'm considering creating an array of like the max possible size, which is the min of size n and m, and then just returning the elements uh, 0 through however many um, elements like end up being in this array. And then a second one would just be to create an array list and then convert that to just like an array for like the result, because we can dynamically increase the size of uh, an array list. So I think I'm probably just going to create an array list if that's okay. Um, And then so I'm going to start by looping through the first array. Oops. Let's see. And then so looping through it there. And then we're going to start with a int start equals I int and equals well, let's see. In this case, am I'm trying to think, am I assuming here that array 1 is larger than array 2 because I don't want to run out of bounds here. So if array 1 is larger than array 2, so I guess I can say so I'll go through the second array here and I'll do a check to make sure that I is not greater than or that start is not greater than end. So I guess I can just do if start is greater than end, just do break. And then there may be a better way to do this, but I think that will work for now. And so I'll do j is less than array 2.1. I'm iterating through the second array here, and actually no. So I guess I don't want to do. I guess I don't really want to do a for loop here. What I do want to do is a while loop, and I can say while start is less than or equal to end. And then I can say int lm is equal to array 2 of start plus end divided by 2. And then I'll say if so if array 1 at element I is less than array 2, is less than lm. So in this case, the element that we're looking for is less than the element which we found. So that means that we want to stay in the left portion of left portion of the two halves of the array which we have. So we'll make end equal to start plus end over 2, and then I'll say else start. Oops. Okay. So yeah, and then oh, well, what I really want is else if array is greater than, then I do this, and then I have the else here, which in this case, these two elements are equal to one another. So I can say result dot add, and then I'll add lm here, and then I will make, oops. And then I'll make I equal to start plus n divided by 2, because I know that if I find this element, every element that we iterate continuing forward in array 1 will be either at that point or to the right of it going forward. Does that make sense?
Not sure. We can test it.
Okay, so I guess like at this point, right? Like let's say for instance that if you can see my highlighting down here, that I'm at, I got to element 6 here in the array, right?
Right.
And I do binary search through array 2, and I find that, I guess that's not a very good example, but I find the element here. So then I know,
Let's start with element 3. Like we both have an element 3, right? And in your case, start position will be on index 0, 1, 2, right? And start will be 2.
right.
Right.
That's a good point. Do I actually want to do this here? I guess going forward in array 2. Um, oh no, so sorry, I'm doing something slightly incorrect here. So which is int, and then I'm going to say um, start is equal to 0, and so rather than setting start to I, when I find the element here, I'm going to update start. Let's see, where do I want to update start? Um,
Yeah, looks like you need to do
actually,
it on like line 10 and that's it, right? Like
yeah.
this.
Well, no, this isn't really what I'm trying to do, because basically um, at the end of the binary search, right? I never want to I don't want to start from 0 every time, right? Because we're wasting time iterating through elements which we know are going to be less than the elements going forward. So um, if I initialize start out here, then um, basically when I finish one loop of the program and say that I've found like a middle element in array 2, then I know that
Yeah, makes
every
sense.
time I binary search from then going forward, I want to start just from the right of that element. You see what I'm saying? So that I don't have to do repeated work just checking a section of the array, which like basically won't yield any results. And then I think I can just do result to array. Oops. I think I can just do this, but I'm not 100% sure.
No, you cannot.
Let's see, convert array list to array. Got it. I think you can just do array. At least it's what it says here in Geeks for Geeks.
Usually you need to use something like stream, map, to read, and something like this. But that is fine. I think we are out of time.
Okay. I'll just go ahead and run the test if that's all right.
I'm 100% sure that it doesn't work.
You're 100% sure it does not work?
Yeah,
Okay. Then I won't run it.
yeah. Let's try.
Oh, okay. Oh, object array cannot be converted to int array.
Yeah, I think you can try to pass it later, but let me show some let me give you some feedback, right? Uh, I really like to approach 1 and 2. To approach 2 sounds good, and that is really fast for implementation, right? That is super easy and readable, and looks like you need to read a bit more about binary search because on line 15 you incorrectly calculate the middle position for element, which should be something like, okay, I'll try to explain. First of all, you don't use the brackets, right? And in your case, if you're using something like this, it will be, for example, 1 plus 10 divided by 2, right? And it will be like 1 plus 5 plus 5. And looks like that is correct.
Oh, I see. I didn't add the parentheses.
Yeah, you can add it like this, but still you will have a problem. What if you have for about 2 millions elements in array, and you're near the end of array, right? And in your case, for example, here will be like 1 million plus like 10 million, and here can be overflow here. Better, that is not necessary. It depends on data to do it something like this. Divide by 2, it will be correct, kinda correct middle position. Yeah. Also, I would prefer to see, like, instead of adding it in a while loop, all this code, I would prefer to see like independent method for it, like binary search, and based on result of binary search, you can add element and so on. But that is like mostly about code style and so on. And also you've spent like more than a minute deciding about array or array list. And in a Java, that is a bad practice to create a class here. Usually it should be a list instead of array list, and then it should be like different realizations.
Okay.
Because that is not the best fit for object-oriented programming. And yes, looks like the base idea is correct, and it should work with some small fixes, and I like it. Yeah.
Okay.
Let's try to swap our roles, right?
Okay.
Oh, and I need to validate IP address. I had it. Validate IP address IP before address is valid if and only if it is in the form exponent where x is a number of 0 to 255. For example, 12 and line IP addresses while 12 1, 2, 3, 4, 5 and are invalid IP addresses. Okay. Before we start, if I correctly understand requirements for these tasks, there should be four places, with digits. Digits, right? Also, there should be 1, 2, 3 points. And that is 1, 2, 3. That is our requirement. Also, we should have a range from 0 to 55 and only digits. Okay, I think I have an idea for brute force solution. Not sure that it will brute force, but okay, let's try. First of all, I can try to split our IP address, split IP by point, and as a result, for example, we have this string, right? And as a result, I will have an array with elements like this, that one, and this one. Then I can check size of the array and return false if something incorrect, right? Otherwise, I can check elements. How can I do it? That is a good question. I can try here to try catch and convert to integer, or I can check every digit. I prefer first variant because in Java we can like beautifully try and catch it, and if we cannot convert it into a digit, we should return it. Or also, if I'm not mistaken, I can find some method, something like isDigit or something like this. And yeah, and that is it. And for time complexity will be bigger from n, because I should iterate over array over array, yeah, over string. Yeah, it should be faster than n. And for the space, it will be also bigger from n, where n will be the size of our IP address. And also I have an idea for the second variant, for the second solution without additional memory. I can use pointers for it. It will be like no?
Sorry, if I could ask a quick question. Where's the additional space coming from in the first approach?
Oh yeah, for sure. I'm splitting array by point, and I need an additional array with string. That is why.
Okay, got it. Got it.
And yeah, second variant without additional memory, I think it will be two pointers. It will be like a start and end. Start will be like a 0 pointer, and will be first point position. Then I can get a substring validate increase point counter, and move to the next. And yeah, for this approach, I need for time complexity bigger from n, and for the space complexity it will be constant. I don't need anything for it. Yeah, what do you think about it?
Okay, yeah, I like your second idea here. But since these strings are pretty small, I think I'm okay to go with approach one just to make it a little bit easier on yourself. Does that sound okay?
Yeah, okay, let's try to do it in the first way. Maybe we'll have some time for the second also.
Sure. I had a quick question. So when you're checking elements and you have this point here, try to convert to integer. I assume you're going to do something like integer.value of, right?
Yep.
Is there any case that you can think of where that conversion would be successful, but it would be incorrect? Like it would be not a valid IP address?
Yeah, like I will have a try catch block, and if I cannot convert it into integer, In a catch case, I'll return false because that is incorrect. Otherwise, I'll check the range from 0 to 255, and also depends on it, will go next or return false.
Can you think of any case where um, the digit, or sorry, so you're given some number, right? And
Or a string, it doesn't matter. It can be
okay,
text, for
sure.
example.
But in this case, it's a string, right?
Yeah.
Can you think of any case where you convert that string into an integer,
Mhm.
which succeeds, and then you check the range, and it succeeds from 0 to 255,
Mhm.
but the IP address is invalid?
But it should be valid.
I think there may be like one type of case where that's not true.
I mean, do you mean something like when we have five uh, elements in an array? Something.
No. So, like, what about the case of something like this?
Oh, and that is invalid, right?
This is invalid because this is supposed to be in the range from like 0 to 255, but it has like a weighting 0. So this would get converted to 1, but and then it would pass the range check between 0 and 255, but this is not a valid number for the IP address.
Oh, okay. Looks like that is corner case for us, and here we can add check start with 0 and length more than 1.
So yeah, you can do it either way. If you check every digit, it could be easier to do it that way, but that's just personal preference. That you
Yeah, checking every digit, that is, it it adds more complication for the code and maybe it should be slower. But okay, yeah. Let's try to implement it and then we'll decide which variant is better. And first of all, I need to split it, right? Split it by point, and it will be a string. How do we call it? Addresses. Like this. And now if addresses line is not equals 1, 2, 3, 4, because 4 we should return false. False. Then we can iterate around the address. I'm not sure that I need I pointer here. Maybe I'm wrong, but let's try to do it like this. And here I can add a try. And the catch. Return false here, right? And it should be integer value of. I hope that is correct. Instruction, something like this. Oh, and also I need to check here if address length more than 0 and address char at 0 position equals 0, we should return false. Otherwise, we check it, and if add lower than 0 or bigger than 255, we should return false. Otherwise, we should iterate to the next element, and after it we can return true. Let's try to test it with our first example and then move to the few corner cases. In the first iteration, I will have an array like this, right? And I'm checking size equals 4. Go next. We have as a first element we have 1, 9, 2, right? And that is bigger than 1 and started with 0, false. Okay, then we convert it into integer that is in a character range. Let's go next. Okay, look, for me it looks fine. I'm not sure about syntax for integer value of and maybe exception.
I think integer value should be fine.
Yeah, looks like it executed without any errors. Oh, that is. Oh, I think I can add free filed. I think there is problem with 0. Oh, yeah, you see, char red, I should do it like this, because that is characters. That, yeah, that is interesting.
Let's see. Address that. 4, which it should be. First thing address and this address link. I believe I see at least one problem.
Yeah, I don't like the case 1, 2, 3. There is no zeros. I thought that it may be problem with zeros, but what if I have this one? 24, 59, and 99, right? I have this array. 1, 2, 3. I've split it, and I have these values. I have 1, 2, 3. That is equals. Yeah, we should go next. Integer 1, 2, 3, and we return nothing. And I go next to 24 in a correct range, right? And then 59 and 99. No, I'm not sure why. I don't have any ideas. What if can I try to validate it here and let's see system Do you see here? Right?
Sorry?
You said that you see here, right? Here.
Yeah, it looks okay to me. Yeah, I'm a little confused as well.
Maybe that is false, but yeah, you see, I'm trying to validate this IP address and that is false, but I'm not.
Uh, you could try adding print statements where it returns false, so you can see where it's returning false from. Is probably what I would try.
Mm, I don't like debug it here because
Yeah.
there is exception here or maybe what is it? I want to add and let's try. Hmm. Oh, that is here. What? But that is impossible.
So it could be here, I guess.
Yes, but there is.
That seems like it should work to me, but yeah, I don't know.
Yeah, but that is something strange, right? Um,
Sometimes the console's like kind of buggy, so it times out.
0. Um, I'm not sure that I fully understand it. Yeah, could you give me a sec? I want to copy and paste it into like IntelliJ and check it because I had to see strange errors during the interview, or like if you don't have free time, I can do it by myself.
Um, yeah, I'm not sure exactly why. I thought your split function would work. I think when I did this, I used the split function and it was fine.
Maybe a point that is a specific character.
Ah, never mind. I know what it is now.
What is it?
Um,
Yes, looks like I need to use escape character here, and yeah, I also found it. Ah, it is.
yeah, that's tricky. I forgot about that as well.
Yes, usually you see this syntax in IntelliJ and like fix it immediately.
Yeah, no problem. I think that's a minor mistake. I think you did a good job here, and you wrote simple code. Um, so I wouldn't focus on that too much. Yeah, in terms of feedback, I mean, I don't have like a ton to give. I think this is a relatively straightforward problem, and you did really well on it. Coming up with like a an additional solution to improve the space complexity, even though the input size is very small is like still a good thing to show to an interviewer. Um, and like kind of using a try catch block here is is good. I would probably catch like a more specific um, exception. Is like one thing I would say. I think it's like illegal number format exception or something like that.
Yeah, because I cannot type it without like keys, you know.
Yeah, I would say that I think it's okay, but if you're going to catch like the exception, maybe just mention like I would catch a more specific exception, but I can't remember like if it's illegal number format exception or whatever. So just like mentioning that shows the fact that like you're thinking about those kinds of things, which is good. Um, other than that, I think that'd probably be my only point. So yeah,
Yeah, awesome. Thanks for this feedback. Just help.
yeah, yeah, no problem. All right, well, yeah, have a nice day.
Yeah, same to you.
Yeah,
Bye.
bye.